Alright, so once again, if you look at the top, we're still on 11.4. Again, yours does not say A or B, but this is just the second part of 11.4 where we talk about triangles. So find the part in your notes where it's 11.4 and it's talking about the area of triangles. Alright, so the area of a triangle is 1/2 the product, so that means multiply, of a base and its corresponding height. So the area of a triangle is 1/2 base times height. And what I would say is, remember, if you're putting the 1/2 in your calculator, you want it as in parentheses. So parentheses 1 divided by 2 parentheses. Or, if you prefer, remember you can use 0.5. So you can do 0.5 times base times height. The other option is, so I've also taught it this way in the past, you can do base times height, and you can divide by 2. So you have to make a decision of which formula you're going to use, and then once you make that decision, I would stick with that throughout so that you don't keep changing it up. I would just memorize one way, and then once you have that, just use that way. Alright, so we're going to practice. The hypotenuse, so we know that means across from the 90, and that's the longest side, of a right triangle is 10 feet, and one of the legs is 8 feet. Find the area and perimeter of the triangle. So if I'm going to find the area, I know I need the base and the height. If I'm going to find the perimeter, I know that I need all 3 sides. So I'm going to draw a picture just so we can see it, and I'm just guessing kind of what it's going to look like. I don't know exactly, but I'm going to say this is 90. I know the hypotenuse, so I know that this side has to be the 10. And I'm just going to take a guess. If the 8 is the longer or the shorter side, I don't know off for sure, so I just have to kind of take a guess. So right here, I know that I have to find this side. And if I'm going to do that, once again, I have 2 sides that are given, and I have 1 side that I'm missing. So to find that last side, I feel like I should use the Pythagorean theorem. Across from 90 has to be the letter C. A and B, I can pick whichever one, doesn't really matter. So when I go to do the Pythagorean theorem, I've got 8 squared plus, I don't know B, so I'm just using x squared, equals C squared. 8 squared is 64. Can't do anything with x squared yet. And then 10 squared is 100. I got to get the x squared by itself, so I'm going to subtract 64 on both sides. X squared equals, when I subtract those, I get 36. And then I have to get rid of a squared with the square root. So x should be 6. So we just found out that this side right here, it's not really x anymore, it's 6 feet. Alright, once again, in a triangle, the base and the height have to be perpendicular. So these two right here make a 90-degree angle. So I'm going to use 6 as the base, and I'm going to use 8 as the height. And I'm going to use the 1/2 base times height. So area is, and then because I'm going to use the 1/2, I'm going to put it in parentheses, so 1/2. And then the base is 6 times 8, and then I'm going to go to my calculator, parentheses 1/2, or remember you can use 0.5 times 6 times 8 is 24. So the area is 24. We're measuring in feet, and since it's area, we know that it's squared. Then we also need to find the perimeter. Perimeter is where we add all the sides. So if I started here and started walking, I would walk 8. Then I would walk 6. And then to get back where I started, I would walk 10. When I add all that up, I get 24. So the perimeter is 24. And since it's not area, it's just feet, regular feet. Alright, trying another one. So we're going to do, we'll start with area, 1/2 base times height. Remember, you can change that to 0.5 if you want, or you could do it as base times height divided by 2. When I'm looking at this picture, remember the base and the height have to make 90. So this side right here makes 90 degrees with this side. So those two sides are perpendicular. And this side right here altogether is 45, and it's also 21. So altogether it is 66. So when I plug it in, I'm going to do 1/2. My base is 66, and my height is 28. Go into my calculator. I end up with 924. I don't know units, so I'm just going to put the word units, but since it's area, I know that they have to be squared. Back to perimeter. Remember, I'm only worried about if I walked around the outside of it. So if I start here, I walk 53. Then if I go here, 35. And then I could do this as 21 plus 45, or I've already done that and found out that it's 66. So I can just say that if I walk all of this, it would be 66. So 53 plus 35 plus 66 ends up 154. Perimeter is 154. We don't know units, but we do know they're not squared because it's not area. Alright, C is a little bit trickier. It says the base of a triangle is 4 times its height. The area of the triangle is 50 inches squared. Find the base and height. So we're not finding area and perimeter this time, we're trying to find the base and the height. I'm just going to draw our triangle so you can kind of see. Again, I'm sketching, I don't really know what it's going to look like. But I know that it talks about a base and a height. So I'm going to make this my base, and if that's my base, I don't have a height right now, but if I draw that orange line, it makes 90 degrees, so now I have a height. Now I'm going to go back and reread. So the base of a triangle is 4 times its height. That means I don't know its height. So if I don't know the height, I'm just going to call it x. The height is x, and the base is 4 times as much. So 4 times x would be 4x, and that's how much the base is. So this whole base is going to be 4x. The other thing I know is that the area, so capital A means area, is 50 inches squared. So that's all I know right now. So what I'm thinking is I'm dealing with area. I have a triangle, so I'm going to write my formula. Area equals 1/2 base times height. And then for this problem specifically, I'm going to change my 1/2 to a 0.5 in the next step. I could leave it as a 1/2, but I just want to make it easier for myself. So instead of A, cross that off, instead of A, I know that I have a number for A. I know that my area is 50. So I can plug in 50 instead of A. So that's not a 150, that's crossed off. Okay, so that's 50, and then I have my equal sign. I'm changing my 1/2 to make it 0.5. Then I have my base. If I look over here, my base is 4x. So I'm going to do 4x. Then I have to do times my height, and I'm going to do times with parentheses. So my height is x. Now I'm going to see what I can do. I'm not going to do anything with the 50 yet. I'm going to keep the 0.5 there for right now. And then if I do 4x times x, that becomes 4, and then the x times the x, remember that's x squared. Still not going to do anything with the 50, but 0.5 times 4, or 1/2 times 4. So half of 4 is 2, but then I still have an x squared. Now it's easy to get x by itself. Right now this is multiplying, so to get rid of it I divide. 50 divided by 2 is 25. These 2's cancel out, so I just have x squared. To get rid of an x squared, we know it's going to be square root. And then on this side we just have x, and over here we have 5. Now if I look back at my picture, I want to find the base and I want to find the height. So x is 5. I know the height is 5. I just plug it back in. But then this one tells me to do 4 times x. So 4 times 5 is 20. So all I did was go plug it back in, and now I can put my answers. So my base, we found out, is 20, and then since we undid the squared, right, it's just measuring the base, so it's just inches, and then the height, when we plugged it back in, it was just x, so it's just 5, and we're still measuring in inches. Alright, last 2 postulates. So these aren't formulas or anything, these are just kind of hopefully pretty obvious ones. If 2 polygons are congruent, remember that means they're the same shape and they're the same size, then they have the same area. For example, if I have 2 things that look like rectangles and they're exactly the same shape, exactly the same size, so like if this and this are the same, and then since they're rectangles, the top 2 are the same, and then if these 2 sides are the same as these 2 sides, so if all the sides are the same and they're both rectangles, then when I find the area, if I do this base times this height, it'll be the same as this base times this height. So since the shapes are the same, their areas will also be the same. Then the area of a region is the sum, so remember that means add, of the areas of its non-overlapping parts. This comes into play when we have some crazy looking shape, and you will see some. But for example, if I had all kinds of crazy stuff going on here, right? Something like that. So I don't have a formula for that shape, but what I do think is I could start splitting this shape up. So I see over here like something that looks like a triangle, right? So if I were able to split that up, I could find the area of that triangle. And then if I were to make a line right here, I would see a rectangle, and I know how to find area of rectangle. Then here I see something that is either a rectangle or a square, but again, I know how to find the area of that. And then if I made another one here, this right here appears like a trapezoid, and we haven't done that area formula yet, but that'll be another one that we go over. And then I have another rectangle. So now that I've broken it all up, I could find the area of this piece, this piece, this piece, this piece, and this piece, and then I could just add them all together because they make one total shape. So make sure that you get the worksheet for 11.4 to practice these, both the rectangles, squares, and parallelograms, and then area of triangles for 11.4.